Good morning, students. So today we are going to discuss out a very important topic. As you can read out, this is written car on a circular level road. So suppose we are on a circular track, and while we are driving in this circular track, then which are the various forces which will act out. So this is what we are going to discuss, and how we should drive and what should be our velocity on such kind of a circular level road. So this is what we are going to discuss. Now I am going to plot out the figure. So a circular road I have shown, and I am going to show a diagram, and the front view of the car I am going to show. So this is the front view of a car. Okay. Now, what is our wish? When we are on a circular level road, we will try to maintain on the circular level road. What is the radius of the circular level road? Suppose the inner radius is small. We want to remain in this circular frame. And once we will wish to remain in this circular frame, there will be a force which will result in the opposite direction of this circular frame. Which force is going to do this job? For example, suppose this is a car and I am turning it here. While I will turn it here in this direction, I will feel out a certain force which is skidding away our tires. The tires will skid away on this particular frame. Means from this circular frame, the tires will skid away. This is a kind of case which we should imagine. We already have faced out in this in the past. So just imagine this picture. I am turning out the car in this direction, and there will be a certain force because of which the tires will skid away. The tires will not wish to remain in this circular frame. That will skid away from this circular frame. So what is that force? We already have discussed this force, and that force which is skidding away our tires from this circular frame is the centrifugal force. A centrifugal force is the force which is always trying to make the body in the opposite direction of that particular circular frame. So the body, the car wants to remain in this circular frame, and that centrifugal force, the tires will skid away in this particular direction. What is the magnitude of this force? By which magnitude these tires will skid in this particular direction? So the force by which these tires are getting this skid is mv square upon r. mv square upon r is actually the force by which the tires are going to skid in the opposite direction. Now, here there will be barricadings of the road. So what is going to be done? Will this centrifugal force will be this much stronger that this will cross out the barricadings of the road and we will meet an accident? And which force can prevent us now? Which force can save us now? So students, once your tire will skid away in this particular direction, in the outer frame of the circle, away from this circular frame, and that is by centrifugal force, that is mv square upon r, then in this case there will be a force which will try to prevent you, to save you, and that force is friction force. Because already we have studied that friction force is always in the opposite direction of the motion of the body. So by centrifugal force, your tires are skidding in this direction, and friction force is in the opposite direction of motion of the body. So friction force, the tires will get it back by the friction. Now that's a very simple case you can imagine. I am just turning out this car, tires are skidding out, and friction is just understanding this, let us show all the forces which are acting on the car. One force is weight of the car mg, and that is in vertical downward direction. One force is normal reaction of this car. Normal reaction, that is always normal to the surface of the body. Remember this point. Normal reaction is always normal to the surface of the body, and the weight of the body mg is vertically downward direction. Now students, what is the magnitude of this friction? How to calculate this friction? Friction is directly proportional to normal reaction R. You already have studied this in the laws of friction. So Fs is proportional to R. Fs is equal to μs into R. So this is the magnitude of the static friction which will get you back in this particular circular frame. Now Fs is equal to, what is the value of R? R, you can see this is balancing of mg. So normal reaction is equal to mg. So Fs is equal to μs mg. This is the frictional force which will make your tires back in this circular frame. Now what is the condition? You will always wish that your friction is greater than or equal to mv square upon R. Friction is saving us. So friction should be either greater than or equal to centrifugal force. In anyhow, this friction should not be less than your centrifugal force. So here we can say that friction is working as our friend. Friction is good for us, bad for us. Here friction is very good for us. It is saving us. Otherwise the tires would skid and we could meet out an accident. So we will wish that friction is greater than this centrifugal force. Now in place of this Fs, we can write μs into R. So friction in place of this static friction, we can write μs into mg. So μs into mg should be greater than v square upon R. Now what will be the condition? Mv square upon R. So m and m gets cancel out. V square upon R, and this is lesser than or equal to μs into g. So v square is less than μs rg, and v should be less than or equal to under root μs rg. So while driving out the car, we should make it sure that our velocity should not exceed this value, that is under root μs into rg. If this value we will exceed out, the meaning of this is that the centrifugal force will be greater than the friction, and if this centrifugal force will be greater than the friction, then no one can save us now. Friction will become less and we will meet out an accident. So for preventing your car in a circular level road, you should not exceed the value of velocity, and that is given by under root μs into rg. So this is the topic R.